I am going to solve quite a few problems using the two pointers. The first problem is 2 sum 2, which is a array problem, and in this the array is sorted, so we can use the two pointers efficiently. First of all, what is two pointers approach? In problems like where we deal with sorted arrays or linked lists, and we need to find a set of elements that fulfill certain constraints. Like here we have an array and we need to find a pair that adds up to a particular uh, target. So this is our constraint here, and the two pointers approach becomes quite useful here. The, like this, the set of elements could be a pair, a triplet, or even a subarray. To solve this problem, the brute force approach could be we can consider each element one by one, indicated by the first pointer, and we then iterate through the remaining elements indicated by the second pointer to find a pair with a given sum. Since this is a brute force strategy, and this will be a time complexity of big O of n square, because we will be using two loops, one loop for iterating over the array and one loop inside to iterate over the remaining elements. So this will be big O of n square, where n is the total number of elements in the input array. Given that the input array is sorted, an efficient approach would be to start with one pointer at the beginning and another pointer at the end. Since we know the array is sorted, the bigger values will be at the end and the smaller values will be at the beginning. So at every step we will check if the numbers indicated by the two pointers add up to a target sum. If they do not, we have two options. If the sum of the two numbers indicated by the two pointers is greater than the target sum, this means that we need a pair with smaller sum. And to explore more pairs, we can decrement the end pointer. Now the second option is if the sum of the two numbers indicated by the two pointers is smaller than the target sum. This means that we need a pair with a larger sum. And then if we need to explore more pairs, we can like increment the start pointer. So apply two pointers here. We can make an example like this one. Now I will call the first pointer left and the end pointer as int. So when I sum them, the sum of these two numbers will be 17, which is greater than target sum. So our first option was if the sum of the two numbers indicated by the two pointers is greater than the target sum, this means that we need a pair with smaller sum. So explore more pairs. What we can do, we can decrement the end pointer, like then it will be here. Now the sum of these two numbers will be 13, which is also bigger than the target sum. So we decrement our end pointer, and now the end pointer is here, and we then sum these two, and these will be equal to our target, which is 9. So we return the indices of this array here. The output expects us to return the indices of such pairs in a array. So we can apply the two pointers here like this way. So what we need to do, I need to declare two variables left and right, which will be our pointers, and then we will loop through the array and we run it until our left becomes less than or equal to the right. Okay, so and inside the loop we will do like increment and decrement our pointers, and we also check if the two numbers add up to a target. So the right will be numbers dot length minus 1, which is the last index of this array, and the left will be 0. Now let's calculate the sum of the current pair. Will be numbers at left plus numbers at right. Now if the sum is equals to target, then we return the indices in an array. Else, if the sum is greater than the target, if the sum is greater than the target, what we do? We do int pointer minus minus, which is our e in this case. Okay, so this is L and E, L and R, sorry. Right. And if the sum is less than the target, then we increment our left pointer. Okay, so this is our loop which will run until the left becomes less than or equal to right. Okay, so there is exactly a one solution, so we don't need any base case or edge case for this. Since this is a one indexed array, so what we can do, we can just the left is 0 in this case, we can do a +1 and also a right +1. Okay, it's not left, it is L and R. Also this one. Okay. Okay, so test cases are accepted. So the time complexity of this algorithm will be big O of n. Since we also discussed the brute force strategy, which are big O of n square. Since we applied the two pointers approach, we have slightly reduced the time complexity to big O of n. Let's submit it. Okay, so all the test cases are submitted. Okay, so the next problem we have is remove duplicates from sorted array. This one is also our array is sorted, so we can use the two pointers efficiently. We are given an integer array nums, which is sorted in increasing order. We need to remove the duplicates in place such that each unique element appears only once. And we also need to keep the relative order of the elements intact. And then we need to return the number of unique elements that we just found or just moved. Okay. So let's take an example and we discuss how we are going to solve this. Okay. So the way we are going to solve it is to in this problem we need to like separate the duplicates in place such that the resultant length of the array remains sorted. As we know that the input array is sorted, therefore one way to do this is to shift the elements left whenever we encounter duplicates. In other words, we will keep one pointer for iterating through the array and one pointer for placing the next non-duplicate number. Okay, so next unique number. So our algorithm will be to iterate through the array, and whenever we see a next non-duplicate number, we move it next to the last non-duplicate number we have seen. Let's understand it with first example. This one. So I will keep one pointer to loop through the array, which will be my I in this case, and I will start from the next non-duplicate number. I will looking from the unique numbers after the ith index. Let's name it as u, which will be unique number, next unique number. Okay, so we compare these two values and we see if they are equal or not. If they are equal, means they are duplicate. If they are not equal, means they are unique. Since the array input is sorted, we know that all the duplicates will be next to each other. Okay, so this is duplicate. What we do, we just increment our ith index, and then we also compare these two values, and if they are equal or not. Since they are equal, this means they are duplicate, so we increment our I. We just loop through the array. Okay, we don't increment our unique number. We will only increment the duplicate next non-duplicate number, or you can say this unique variable. We only increment it once we find a unique number, and we then place that unique number at the index of nums at u, and then we just increment our u to look for the other next non-duplicate numbers or unique numbers. Okay, so in this case they are unique. I is at 1 and 0 is pointing u is pointing to it 0, so they are unique elements. So what we do, we place the 1 here. Let's consider this one is a resultant array. We place the 1 here at the index of num set u, and then we increment our u as well. Okay, we also increment our I, and now they are not unique since they are pointing to the same element here, 1 and 1. So what we do, we just increment our I. We will keep incrementing the I until we encounter a duplicate number or a unique number. Okay, so still I pointing to 1 and u is pointing to 1, so they are still not pointing to the unique number. Okay, so we increment the I, and now the I is pointing to 2 and the u is pointing to 1. So the 1 and 2, they are not duplicate numbers, they are unique numbers. So what we do, we move the 2 at the num set u. Num set u, we move it the num set u. Okay, so we just move this 2 here at num set u, and we need to increment this u. And now the I will be at this one 2. Okay, so there we compare these values. The values at num set u and num set I are the unique. Since they are unique, so what we do, since they are unique and since they are unique, we place this 2 at the num set I, and we also need to check if we have this duplicate number in array already. So we have this 2, we just skip this one. Okay, okay, so we point to the here 3, and now we have the unique number 1 and 3, and we place the 3 at the num set u, which will be 0 1 2 3, and we also increment our 3 here, and also increment the u, will be here. Okay, so they are still pointing to 1 and 3, so they are not unique since this 3 already is contained in the array. So we just increment this one, and we found a unique number. So we place this 4 at the num set u, which will be at this index, and we don't care about rest of the elements that will be duplicate. Okay, we don't care about them. So how many elements that we have shifted, which will be the count of this num set, which will be count of the unique numbers that we have just shifted. Okay, so we have just shifted 5 elements. If you count them, it's up to 5, so the output is 5, and we need to return this nums. Okay, we don't care about the rest of the elements. Okay, so this will be our algorithm. How we will be solving it. let's declare the variable I. The I is for iterating through the array, and let's consider it next non-duplicate number instead of u. Since we will be placing all the next, looking for the next non-duplicate number and placing them at their correct position. So we're starting from the second index, which is 1. Then we start comparing them. We do this inside this loop. This loop will run until we hit the end of the length. This means we are traversing through the array, and then we compare the elements. The value at next none to minus 1 is not equal to num set I. Okay, so we are also considering our first element as well. We need to place it. So the first element at num set I, which is 0 and 0 is not equal to 0. Okay, so we place this 0 it is first place, which will be the num set I. Okay, and then we just increment also the next non-duplicate number. So look for the other unique numbers, and we do the I++ to look for to iterate through the remaining elements as well. Okay, so this is our algorithm. What this do for okay, so our nums at I and nums at next non-duplicate number are not same. This means they are unique number. The all the duplicates values will be next to each other. Okay, so nums at I at next we also considering the first element, and then we placing the next non-duplicate numbers at the correct place. Okay, let's run this. Okay, so we also need to return the count of this next non-duplicates. Okay, all our test cases are accepted. Let's submit it. Okay, so the next problem we have is squares of a sorted array. We are given an integer array nums sorted in increasing order, and we need to return the squares of each number sorted in increasing order. So the way we can solve it, we can use a brute force approach to traverse through the array and calculate the squares of each number. We can store the squares in new array and then sort the resulting array using any sorting algorithm like quicksort or merge sort. Because of the sorting, this approach has a time complexity of big O of n into log n, where n is the length of the input array. Can we do better than this? Can we about sorting? Is it possible to generate output in sorted order? Can we code a big O of n solution? An optimal approach could be to use 2 pointers starting at both ends of the input array. Similarly, what we have done in the 2 sum 2, where we initialize 2 pointers left and right, left pointing to the first element and right pointing to the last element of the input array, and then we are calculating the sum of those. We can follow a similar strategy here. So at any step, whichever pointer gives us bigger square, we add it to the result array and move to the next and previous number. Okay, we will be appending the bigger square because the 2 pointers are moving from larger square to smaller squares. For that, we will be inserting the squares at the end of the output array. We initialize 2 pointers left and right. Left points to the first element and the right points to the last element in array, which will be nums dot length minus 1. These pointers represent the indices of the elements at the start and the end of the array. we can then enter a loop while left less than is equal to right. Okay, in each iteration we calculate the squares of elements at the left and the right indices. So the nums at right, nums at left. And similarly we have to calculate the squares of right square and okay. We then compare left square with right square. The larger of these two squares is inserted at the position of the we also create a variable highest square index and set it to like nums length -1, the last index of the squares, which will help us populate the squares array from the highest rightmost index towards the lowest index. Okay, so it will be nums dot length -1, and we also create a squares array of the same length to hold the squared values. Now we call the array and nums dot length. Okay, we then compare left square with the right square. The larger of these two squares is inserted at the position of highest square index in the squares array, and highest square index is decremented. Okay, so we place this in the highest square. So the bigger square is the left square here in this case, and we do highest square minus index minus minus, and this is right squares array. Else what we have, else the right square is greater than the left square. So in that case, if the right square was larger or equal, we decrement right to move towards the lower numbers in the array. We are comparing absolute square values, so even if numbers in the array are negative, we are dealing with their positive squares. So in this case, the bigger is the we place the highest square index, which will be the right square, and we do we do here left square, left plus plus, and we do right minus minus, and in each iteration we will decrement this highest square index by 1. Okay, this one is squares array. Okay, and then we return the squares array. Okay, let's take an example or this one. Okay, the left and right is here. Okay, so the square of 10 is going to be 100 and square of 4 is going to be 16. So the bigger square here is 100, so we put the 100 inside our squares area at the last index. Okay, and then we do what we do, we do right minus minus. So the right is here 3. So the square of 4 is 16 and the square of 3 is 9. So which one is bigger? 4 is big. Square of 4 is bigger. So we put the square of 4 here. And we do left plus plus. Right is pointing to 3. Okay. So the square of right is going to be now 9 and the square of left is going to be 1. So which one is bigger? 3 is bigger. So we put 9. And then we do right minus minus. Okay, so the left is pointing to the -1 and the right is pointing to the 0. Okay, so square of 1 is 1 and square of 0 is 0. Okay, so which one is bigger? 1 is bigger, so we put 1. And now the left is equal to right. Okay, so we put the square of 0, which will be at 0, and this will be our output for this array.